welcome to everyone. Today we are going to start another session on compute network, which is network layer. So in this session, we are going discussing about what is network layer and what is the functions of network layer and what is the design issues of the network layer. So while discussing about these previous sessions, we discussing about this OSI reference model as well as we discussing about this TCP/IP reference model. So when discussing about this OSI reference model and this TCP/IP reference model, we have 7 different layers are there, and in this one we having as a 4 to 5 different layers are there. So after this one, the first layer is a physical layer and second layer is a data link layer, which is apparently we having as a logical link layer as well as we having as a medium access control layer. And after this one, the next layer we having as a network layer. So when go for this TCP/IP layer, these two layers are forming a single layer that we calling as a physical layer, and the next layer we calling as a network layer. So what is meant by this network layer and what is the usage of this network layer and how it is helpful for in the data communication while information is transmitting from one station to another station. So we are going to discuss a detail about in this session. So while coming to the first one, what is the functions of network layer? So functions of network layer. So when discussing about this previous layer, which is data link layer, the information is transmitted in the form of frames. So whatever the information we have, that one, all the things we able to transmit the information in the form of frames as well as we receive in the information in the form of frames one, which means whatever the data we're grabbing from physical layer, which is binary number ones and zeros, we forming into a frames. What is a frame? Frame is nothing but a group of binary numbers, which is digits or bits, that's we calling as a frames. So in the network layer, data is transmitted in the form of packet. What is a packet? Packet is nothing but a group of frames that we calling as a packet. So information we are able to transmit from packet, which is in the form of packet section from one station to another station. So it is helpful for delivering data from source to destination. And when discussing about this network layer, so when discussing about this packet structure, but what is meant by this packet structure and what is the size of this packet and what is the how to design this packet and what is the length and what is the structure and what is the architecture of this packet, we are going to discuss in detail in the next upcoming sessions. So but what is a packet? Packet is nothing but multiple frames are there. All the frames we formed into a group of structure that we calling as a one packet of thing. So it will be helpful for encoding the section as well as for decoding to send information to the upper layer values only. So here network layer is basically used to when we want to send information from one station to another station. So we can go for this, we are using a different kind of networks, we are using that one. So think it this way, for example, we are information transmitting from in the mobile situation. So this may comes to this one network tower location and the information transmit to the next location. So it will be grab the network, another network, and information also transmit from one network location to another network or one network place to another network. So here we can able to send the data over the different networks. It is feasible for data transmission from various network, various data sources. It is feasible in using the network layer. And in the network layer also we are using this logical addressing, which means data sent to the same network. For example, if we are able to transmit data in the same network, so to address is same as well as the from address is same, which means data is sent in the same network. So there is no need, which means we generally need the physical address, but same we need physical address, but we want to send outside network, we need the logical address. For example, I'm establishing one kind of LAN connection, which means local area network connection. Within this network region, we having as a specific particular IP address we have there. We having as a physical address value is there, but information is transmitting from one network to another network. So here we are having as a logical address. That is the difference between within the network region as well as in the outer network region. So here network layer also helpful for send data outside network as well. And while the another important advantage of this network layer, which is routing mechanism. So what is meant by this routing mechanism? So while information is when go for this different kinds of packets or different kinds of frames are transmitting, so we have to give the prescribed path, a specific routing path to information transmitted from source to destination. So that kind of path also we are going to using. We are going to give the routing mechanism to the information transmitted from source sender. So what kind of packets we are transmitting, we are also design the routing architecture as well. So but how these are working? So when the routers or switches, those are connected to the network layer, and this route is helpful to while information transmission from one packet to the final destination. Assume that one. So for example, I am having as a 10 different packets, or this a packet 1, packet 2 and packet 3 is there. So information is transmitted from source to destination. So while information is transmitted from source to destination, so I need to give the shortest path. So the information transmitted from source to destination. So here the routing mechanism, which means we have to give the shortest path to reach the destination person. Or else while you go for this real-time application, so we having as a navigation is there. So all the people we are using this Google Maps, we having as Gmaps, navigation is there. So while we enter from two place to destination place, they may give the multiple destination, multiple paths, they may choose that one. But out of the multiple path, they may give the based upon the traffic density and based upon the distance of kilometer value, they assign the shortest path to us. They given the suggestions to this is the shortest path and how much time it will take. All the things displayed while we go for this navigation section. Similarly, here also, while information is transmitted in the form of this packet section, so it has to give a routing path. So that routing path which will acting as a shortest routing path. So the information is transmitted from source to destination. It has to analyze which path is shortest path. The information is transmitted from source to destination. So that is a major advantage which we are using the network layer. And in the network layer, while we assign the data transmission from one place to another place, one station to another station, while design the shortest path as well, and information transmitted in the logical addressing are the one network to another network. So we are facing some kind of design issues are there that we calling as a network layer design issues. So what is network layer design issues? So first one is we are using this store and forward packet. Second one is service provided transport layer and implementation of connectionless as well as connection oriented services. So as we discussed in previous sessions, while we using this data link layer, we are able to develop the multiple protocols are there. We develop the stop and wait protocols, or we develop the go back and protocol. So based upon this protocol, the frames are transmitted accurately. We are getting this some kind of acknowledgement services are there, and some scenarios we are getting this unacknowledgement services are there based upon the connectionless communication as well as connection oriented communication. Similarly, in the design layer issues, the network layer design issues as well, we having as a multiple design issues are there, which means we are store and forward packet services, which means the information is transmitted from one place to another place. First we have to store the data, then we have to move the data forward data from source to destination. And next one is services provided to the transport layer. So what are the data we are getting from the data link layer? So this layer information is transmitted to the next layer, the upper layer, which we calling as a transport layer. So what are the data we are getting, what kind of routing mechanism we are giving this, and what kind of transport path we are giving this one, that is also provided services to the next layer, which is a transport layer. And these also supporting to the connectionless services as well as connection oriented services. So what is mean by that one by one? What is the design issues? How we are facing these design issues? So when you go for the store and forward packet switching mechanism, so in the store and forward switching mechanism, so what is mean by this store and forward packet switching? So first we understand, for example, we having as a multiple frames are there, multiple packets are there. For example, we having as a 10 different packets are there, or as n number of packets are there. So these packets are transmitting from source to destination. So the packet 1 is transmitted, packet 2 is transmitted, similarly n number of packets are transmitted. So first we have to store the packets, we have to store all the packets together, and based upon the routing path, based upon the shortest path, we analyze that one, that path is forward to the destination section. That means we calling as a store and forward packet. First we have to store the data, we have to store our packet section, what are the packets we are getting from the source section, we are storing those amount of packet, and we analyze the shortest path here. From that path, once after the analyzing shortest path, so all the packets, what are the data, what are the packets we stored, that one we are pushed into the destination section values only. So we'll see this one, we having a different kind of hubs are there. So this hub 1 we calling as a source section, and this hub 2 we calling as a destination section. So here we are able to process the data, so one place to another place. So here information is moving to this A section, which means the packet is coming to this A section. So here we are able to analyze the shortest path. So for example, A to B we having as a two packets we received, but the distance should be 2, but in the A to C we having a distance of 1. So we are push this packet 1 to A to C direction, and from A to C direction, as well as from moving data from C to D as well we having as one option, as well as C to E also we having as another option. So again we have to choose the which is the shortest distance, either the C to D is the shortest distance or as C to E is the shortest distance. For example, the distance of C to D we having as a 3 and distance of C to E we having as a 2. So we have to choose the path of C to E, that is a path of 2. And similarly we having as only one direction, which is E to F. We choosing this direction, which we calling as a E to F mechanism. So when you see this one, here we are able to choose direction should be A to C, and next one is we have to choose C to E, and next one we have to choose is E to F. So the forward direction is A, C, E and F. So this is the shortest path value. So this path, while running this kind of architecture, we are going to develop the multiple protocols are there, multiple algorithms are there, like Bellman-Ford algorithm or bridge algorithm. Some multiple algorithms are there to develop this kind of shortest path algorithm. We discuss down the line those kind of algorithm as well. So once data is reached into the H2 position in the receiver position, that means data is forwarded. So here in this architecture, we are using multiple routers are there, multiple gateways are there, which means all the things are a carrier equipment which information is transmitted from one station to another station, which means we calling as a store and forward packet mechanism. And next one is we are going discussing about the services provided to the transport layer. So as we discussed, the above the layer, then the network layer, the upper layer we calling as a transport layer. What does transport layer do? Transport layer do the routing mechanism to the respective packets. So that is the routing technology. We again forwarded the based upon the transport layer, which means we are provide some kind of transport services to the information carrier. So that kind of services we provide the network layer, that should be independent of a router algorithm. We develop the based upon different algorithms, we develop that one, that the algorithm which should be a independent, that should be helpful to a routing mechanism, a routing technology. And this transport layer should be a share the a number of types, topology and what kind of routers we present. So as we discussed, we have a number of topology services are there. So when discussing about topology services, so we having as a various topologies are involved in this services. We calling as a star topology, we having as a bus topology, we have as a ring topology. So multiple topology services are there, while information is transmitted from source to destination. So that kind of services is provided to the transport layer. Network layer provide services to the transport layer, because so these kind of, for example, we go for this ring topology, or else we go for this a bus topology services. So when information is transmitted, the bus topology services or a ring topology services. So here, while this also we are going to assign the a routing path, we are going to analyze the routing path. So that kind of routings also we are using various routers also present in the services, that kind of service also provide to the network layer. And network layer, the address made the available transmitter, there should be a uniform number value across the LAN connections or WAN connection. What is mean by this statement? When go for this the network layer, so as we discussed in previous slides, the network layer is provide services to the a different kind of network functionality as well. Information is transmitted from one network to the another network as well. So here we are able to develop the various LAN connections or various WAN connections, which means we have to develop the local area network, multiple things, as well as a wide area network. And next one is implementation of connectionless services. So what is meant by this implementation of connectionless services? So in the connectionless service, the name itself is there, it's a connectionless service, which means we don't have this any kind of physical structure we are required for this one. So when go for this a routing datagram of this sub packet, which is we calling a subnet of things, when you see this one, here the information is transmitted from source to destination. He has to choose the path. A to C is the 3 packets and A to B is the we having as a 4 distance of packet. So here various routers we analyze that one, and after this router, which is the shortest path for that one, while implementation the connectionless services as well. For example, we are able to transmit signal in the air domain in the connectionless communication, which apparently we calling as a wireless communication. So in the wireless communication, air acting as a medium. So even though the air acting as a medium, from this as well, so what kind of direction the signal is transmitted, whether go for this unidirectional one, whether go for this bidirectional one or as omnidirectional one, we have to choose the communication path and what kind of direction signal is propagated from source to destination. At the same time, what kind of packet structure we are using that one and which is the shortest path. So when see this one ACEF, which means we have a 3, 2 and 1. So the total size should be 3 plus 2 plus 1, which is total size should be 6. So once we choose the shortest path, for example, we having as a path of A. So path of A can able to choose either path B direction or as path C direction. But we having as a shortest path packet should be A to C, that is 3. So this packet is we ignore the down the line. So this direction we are going to ignore. But at the same time, we have another option is there. Once the data is received from A to C, data can move into from C to D or else C to E. If C to E is moving, so this is the shortest path. There may be chances of C to D path is more than this 2 value, maybe a 3, 4 or whatever is the value, but more than this 3 value, we can able to choose this path value. So after this one, choose this path, that is a F1. So final data received at the F state, which is a connectionless communication state. At the same time, in the connection oriented communication, so here we calling as a virtual circuit. So we having two things are there. We having as a packet switching is there, and the sense a packet circuit is there. At the same time, we have another thing we calling as a virtual circuit or else virtual packet. We having that one. So here we having as n hubs are there. For example, we having a hub 1, hub 2, hub 3. So n number of hubs are there. So all the information is transmitted to the packet E or router E. That router is for the information to the next shortest router path value, which is A to C, C to E and E to F value. So here multiple routers are involved here. Well, see this previous slide. So in the slide, we having as only one hub, which is source hub, as well as another hub we having as destination hub. But in the connection oriented one, when we go for this, when we design the virtual routing network mechanism, virtual circuit mechanism, multiple hubs are involved. They may be acting as a multiple sources or one destination, or maybe chance of the one-to-one communications or one-to-many communications are involved in this virtual circuit subnet. So here information is transmitted from A to C value, C to E value and E to F value. Here this carrier mechanism, the entire carrier mechanism, n number of routers are involved. That routers must be a shortest path algorithm routers. That is a advantage of this connection oriented communication. So while we're discussing about this application perspective, while you go for this a connectionless communications or connection oriented communication. So when you go for this application perspective, in the connectionless communication, when you go for this, apparently we calling as a wireless domain communication. In the connection oriented, which may acting as a wired communication, but this may also having as a develop the one kind of intercom services that may be a shortest path services from one network organization to another network organization. That feasibility we have that one. That's the reason we calling as a virtual kind of circuit mechanism, virtual kind of subnet mechanism. So I'll conclude this session. So in this session, we are discussing about this functions of data link layer as well as design issues of data link layer. So what is the functions of data link layer? It has to provide the services to transport layer, and it has to provide the services to the information is transmitted to the one network layer to another network layer, or it may be chances to one different kind of domain networks, one network domain to another network domain. And apart from this one, the another important one, here we have to choose the shortest path algorithm. We have to give the shortest path algorithm. Is one of the major advantage of this network layer. And what is the design issues of this network layer? So while common design issues, we have multiple issues are there. Basically we having as in the connectionless services issue or as connection oriented service issue, and we having as different things are there. We'll go for this services for transport layer. So here where we design this network layer, where we establish a network architecture path, here multiple routers are there, multiple hubs are there. So how we are able to assign these hubs? How we are able to assign these hubs to my router path? Right. So that is the important design issues. While establishing this kind of communication architecture, multiple hubs are there, single routers are there, but we are able to choose the routing path mechanism to information is transmitted from one station to another station. We have to choose the shortest path mechanism. So that may helpful to design this routing algorithm. So in the next session, we are going discussing about this, what is the shortest path of the routing algorithm. So which means information is transmitted, information is carried from one station to another station, how the shortest path algorithm is analyzed, because the entire network architecture is based upon the analyzing the shortest path values only. So with the help of this routing algorithm, we analyze the shortest path. So that we are going to discuss in the next session. Thank you.